Hello, everyone. Okay. Hello, everyone. This is Shiv Prasad. I will be your instructor for Mule 4. So, this is the first session, and I hope you all have the prerequisites for this course. So, today, first, I will introduce you to the course. I'll give a high level overview about what we are going to cover and what we are not going to cover. I will set the expectations right and then I'll take it forward. So I hope all of you are able to understand whatever I am speaking as you are from different time zone. I will try to speak in this way so that everyone can understand whatever I am speaking. I'll try to speak slowly. Okay. So let us get started. So the prerequisites for this course are you should have basic understanding about SOAP, REST, and messaging, and a very basic understanding of core Java will be good. Just a minute. Okay. Um, so first, I assume zero knowledge on Mule from you. I will start from zero and then I'll take you to advanced levels. So first, we will try to understand why Mule or why any integration product. First, we'll start with understanding what is the problem with point to point integration. Actually, what is a bus and what is an integration service bus? How ESB helps in solving the problems with point to point integration. We'll understand how ESB works. Then today we will try to understand what is orchestration, what is Mule, and then what is this any point platform for Mule. Once we are done with basics, we will try to create a Mule application and try to understand what is a Mule flow, what are event processors, and how a Mule event looks like, what are transformers, endpoints, etc. I will introduce you to any point studio, which will be our IDE, and we'll see how the Mule project will look like, how to debug Mule flow, and how to track event in MuleFlow. I will introduce you to DataWave as Mule expression language. This is just an introduction to DataWave. And this course will be a practical course. After every module, whatever I complete every day, I will give you an exercise. Actually, I will demonstrate the concepts using an example live, and then I will ask you to work on an exercise which you have to complete before you come on next day. And if you have any queries or any problems implementing the exercise, next day, whenever I start, we can start a discussion regarding the queries. And then we'll go into topics. Okay. So once we are done with basics, then we'll understand what are modules in Mule. And we'll start with a basic Java module. We will see how to call static and non-static methods in Java module. Then we will try to deploy our applications on standalone runtime and also using runtime manager. Then we will try to consume a SOAP web service, various configurations related to consuming SOAP web service we will discuss. And then we will understand how to consume SOAP web service. Here REST web service and here SOAP web service. While discussing about these consumptions, we will also discuss about a router called as choice router. And then we will see how to process files using file connector. And then we will see how to connect to databases using database connector. And I will show you how to fire various types of queries. Then coming to best practices, we will see how to externalize the configurations and secure the properties. Then we will see how we can migrate our applications between different environments like dev environment, production environment, etc. And then we will see how to trigger a flow when a new record is added. And most importantly, we will understand what is watermarking. Then after that, we'll understand what are object stores, and we will do manual watermarking using object stores. Then comes the important things like domains. We will understand what are domains, why domains, and we will try to use it. And then we will have a discussion on various other routers available in Mule 4. And then we will discuss about JMS endpoint, how to send and receive messages using JMS module. And then comes the most important topic, data view, transformations using data view. We will start with simple transformations. Step by step, I will make you to understand how to write functional programming. Actually, data view is a functional programming language. How to think functionally, how to write expressions very easily. We will very good examples. So we'll start with basic data view to complex. We will understand the most important transformations, like how to transform from XML to JSON, JSON to XML, Java, CSV, etc. And then we'll see how to create data view, etc. Then there are a lot of important functions, data view functions. By the end of data view, I will make sure that you will know everything to write transformations, handling or error handling. How to test your Mule flows. Mule offers MUnit, which is a testing framework. We will see how to write test cases for testing our Mule flows using MUnit. And then we will discuss about what is this batch processing, how MuleSoft helps in processing bulk records concurrently using batch module. And then we will see how to deploy our applications to Cloud Hub. Actually, I will introduce you to what is a platform as a service and how MuleSoft offers Cloud Hub as platform as a service. And we'll see how to deploy applications to Cloud Hub. Once we are done with until this, we will actually discuss about various ways to develop Mule applications. Basically, in Mule applications, we follow API-led connectivity. I will introduce you to what is API-led connectivity, and then we will understand different kinds of APIs like experience APIs, processing APIs, system APIs. Once we have idea about what is an API, we will design APIs using RAML, RESTful API Modeling Language. And then we'll write an implementation for the APIs, and then we'll see how to manage the APIs using API Manager. Okay, so this takes us to the end of the course. I have described what we will be learning. These are all the topics we will be learning. And this is the actual agenda for MCD, MuleSoft Certified Developer Exam. So if you are planning to complete that certification exam, whatever topics are required for clearing that MCD, MuleSoft Certified Developer Exam, I'm going to discuss in detail, and you will be confidently able to clear that exam after this course. Okay, so we have 40 hours of the session, and every day you might have to work for another 1 hour. So you will listen to my lectures and demos for 2 hours in a day, and you might have to again spend at least 1 hour for completing the exercise. So for next 20 days, I request you to spend at least 2 plus 1, 3 hours minimum on this mule, and I will ensure that after 20 days or whatever the course is completed according to the schedule, you will become very confident on mule. Okay, let us get started without any further time waste. So let us get started with the topic. First topic: what is a problem? Traditional problem with point to point integration. Okay, so what is an integration? Let's assume that some third party is exposing a SOAP web service. For example, they have their application and they're exposing a third party is exposing a SOAP web service. And my application has to consume that third-party SOAP web service. So assume that I am writing my application using Java. It can be anything, but assume that I am consuming the SOAP web service in Java. Assume that the SOAP web service is developed using some other language, let's say .NET or Python or whatever. This is a SOAP web service and I am writing my Java application and here is my code. Now, whenever we are consuming a SOAP web service, definitely we need to know the contract of the SOAP web service. I hope all of you know we write SOAP contract in a WSDL, web service definition language, WSDL. So we will be getting the WSDL from the third party. Normally, if I am writing a Java code to consume SOAP web service, what I will do, from this WSDL, I will generate code using some tools. There are tools which will generate Java code. From the WSDL file, we can generate some Java code using a tool. Then using that generated code, I will write my logic to consume this SOAP web service. I can say that my application is integrating with third-party application. I am doing integration. So, what are the problems right now? First of all, if I am doing integration, I will think about how am I coupling my application with the other application. So, first I will think about whether my application is loosely coupled or not. So, in any integration, you need to check whether you are having loose coupling or not. What do I mean by loose coupling? Suppose, actually, as I said, there will be a contract between the consumer and the provider. What is the contract in this case? WSDL, right? If I have to say that my application is loosely coupled with other application, there is some rule. What? Even though there are some changes at the implementation level, if the client code need not change, as long as contract is same, we can say that these two applications are loosely coupled. So what do I mean? Assume that we have a contract, WSDL file, and today the implementation is done using .NET. But somehow they changed the implementation. Instead of .NET, they are using, let's say, Python and exposing the SOAP web service. The implementation details changed, but the contract is remaining same. Do you think my code should change now? No, right? As long as the contract is same, my code will not change. Even though some implementation changes are there. So if I do such an integration, then we can say that these two applications are loosely coupled with each other. Yes, whenever I am consuming a SOAP web service using SOAP over HTTP, whenever we are sending and receiving messages, SOAP messages over HTTP, definitely we achieve loose coupling, because if contract is same, then this consumer code will remain the same. Definitely we achieve loose coupling. But the next coupling which I would look is logical coupling. I will see whether these two applications are logically coupled or not. What do I mean by logical coupling? Logical coupling means if there is an integration in such a way that the service provider does not know who is the consumer, and consumer does not know who is the producer. Where is the producer? Consumer does not know where is the producer located and who is the producer. If integration is done in such a way that client need not know who is the service provider and service provider need not know who is the client, but still client and the service provider talk to each other. If I have done such integration, then I can say that these two applications are logically coupled. But in this case, when I said Java application is consuming SOAP web service based on the WSDL, don't you think my code needs to know the endpoint URL of this SOAP web service? Yes, right. My code should know the endpoint URL of this SOAP web service. Then only it can send SOAP messages to SOAP web service, right? So my code should know where is the service provider located. It should know the URL, right? Okay. And also my consumer code should know that the other party is a SOAP web service and not a REST web service. Because my code has to create a SOAP envelope if it knows that it is talking to SOAP web service, or else it might have to create a message required as per the REST web service if it knows that it is consuming a REST web service. Okay. So in this case, my code should know who is the service provider, SOAP or REST. Where is the service provider? So my application, if I'm consuming using SOAP or HTTP like this, my application is not having logical coupling. No. So how to achieve logical coupling in this case? Let me explain you. Again, assume this is your SOAP third party SOAP web service. And here is my application. And this is my code. Normally, what our code should do, it should create a SOAP envelope and send it over HTTP. But now I will change the idea. My code will not create a SOAP web service. Actually, it will not create a SOAP message. Sorry, my code will not create a SOAP message. Actually, whenever I say a message, every message will have headers and payload, right? Even SOAP message has headers and payload, right? Now my code, I will write in such a way, it will not create a SOAP message. It will create a message in some proprietary format. my code will create a message in proprietary format. And whenever I say message again, this has its own headers and payload. And then in my application, I will somehow create a in-memory queue and put this message inside this in-memory queue. Then if I have some component like soap adapter, soap adapter is a component which I configure, not write the code. Okay, I'll configure a soap adapter to pick the message, whatever is there in the queue, convert whatever message into a soap message. Again, these headers in proprietary format has to be converted to soap headers. This payload has to be converted to soap payload. The soap adapter will convert the message to soap message and it will make a soap call. Now, see here, this is the code which I am writing. In configuration, I'm going to create a queue, in-memory queue. And in the configuration only, I'm going to configure a soap adapter. It's only in the configuration. Now tell me, is my application logically coupled or not with the other application? Do you think my code is creating soap message? No,
Yes.
right? No. My code is creating a general message in a proprietary format and putting it in the queue, in memory queue. This soap adapter is converting this proprietary message to a soap message, and then it will make a call to the soap web service. And this is in the configuration. So while writing code, I am not creating a soap message. So what is the advantage? Assume that the third party says, hey, we are going to stop support for SOAP web service in next few months, and we are exposing same functionality using REST. Do you think my code will change? No. My code will still create a message, general message, and keep it in the queue. But in the configuration, I will remove this SOAP adapter and make it as a configure a REST adapter. So this will take care of making REST API call. So my code is not changing. My code does not know whether it is consuming a SOAP service or a REST service. And my code need not know what is the endpoint URL. It is in my configuration. So my consumer code is talking to third-party application without knowing what type of application is it. Is it a SOAP web service or a REST web service, or is it some other thing? It doesn't know. Still talking, right? So I can say that my application is logically coupled to other applications. Okay. So normally, whenever we are doing integrations, we need to make sure that our application is both logically coupled and loosely coupled, both. Okay. Now, we understood the advantage of logical coupling because my code need not know who is the producer, whether it is soap or rest. So tomorrow, if I want to change from soap to rest or rest to soap or whatever, I just need to change the adapter, right? Okay. Now, let me tell you some more common requirements. Assume that this is my application and here is my code. Let's assume that my application is getting a request and my code is executed. My application, my code got some data and my application should process that data and give the response. Now, once the data comes, assume that I might need to invoke a SOAP or REST web service and then give the response. Once the data comes, maybe even before invoking this web service, I want to check whether this data is valid or not. So what I can do, once my code receives the data, it will create a message with that data. Whenever I say message, again, it will have headers and payload. Whatever data my application is getting, using that data as a payload, a message is created, and I'll keep it inside the queue, in-memory queue. Now, even before the request reaches web service, I want to check if the data is satisfying some conditions. If the data is satisfying the conditions, then only I want to proceed further and invoke web service. Otherwise, I don't want. So what I need is a component which can take this message and check for some conditions. So we need something called as a filter. Filter takes a message and checks if that message is satisfying some criteria, whatever we configure. If everything is fine, the filter will keep the message into the next queue. If the conditions are not satisfied, the filter may throw an error or give some error response. So filter is the component which I need to check some conditions if they are satisfied on the incoming data. It will filter the data. Only the filtered data satisfying the conditions will go to the next level into this queue. Then assume that the data whatever I got is in JSON format. But while sending the data to SOAP web service, I might want the data in XML format. So maybe I need a component which can do some transformations, transform XML to JSON or JSON to XML, etc. And the transformed message, it should keep it in next queue. Then from here, I will configure an adapter, whatever it is, SOAP adapter or REST adapter, etc., which will actually invoke the web service. Now, the question is, hey, do I need to write a filter logic, filter, transformer, and adapters? No need. If there is a framework or a library which can provide me ready-made filters, transformers, adapters, etc., I will be happily able to use such a framework or a library. Okay. So there are a lot of such libraries which will provide us with components like filters, transformers, and wide variety of adapters like SOAP adapter, REST adapter, SAP adapter, Salesforce adapter, database adapter, FTP adapter, like that. Wide variety of adapters. So there are frameworks which are providing wide variety of adapters. Now, such frameworks are called as bus frameworks. Why the name bus? Normally, in a bus, we travel from one location to other location. Here also, in our application, the message is traveling from one location to other location and coming back, right? Here, I can say that my application is having a bus like infrastructure because my message is traveling from one location to other location and coming back through these channels, filters, transformers, adapters, etc. So any framework or a library which allows me to create such bus-like infrastructure and any such framework which provides me ready-made components like filters, transformers, wide variety of adapters. And this library allows me to create in-memory queues and configure everything. Such library is called as a bus library or a bus framework because using that framework or library, I'll be able to create a bus-like infrastructure through which my message will travel. So whenever we are doing integration, whenever my application is integrating with other application, we need such bus framework, right? Otherwise, we have to write all this. Mule is one of the bus framework. Actually, we call Mule as a ESB, Enterprise Service Bus. What is this Enterprise Service Bus? Why the name Enterprise came? What is the difference between a bus and an enterprise service bus? Let me tell you. In your enterprise, which is a bigger organization, you might have multiple applications for different products. For each application, don't you think security is a common thing? You need to secure your applications. Definitely security is required for every application within your enterprise. And also transaction management. Transaction management means what? Either everything is committed or everything is rolled back. Maybe in terms of a database or a message broker or whatever. Transactions are also common requirement for most of the applications in enterprise. So there are some common requirements like security, transaction, and pooling. Pooling objects or threads is also a common requirement. So like that, there are some enterprise-wide common requirements. Now, whenever I'm developing an application A, application B, application C. If we are writing code for security, transactions, pool management, etc., for each and every application, again, it is duplicate, right? Duplicate code, same code I am writing in all these applications. So what I want is, I don't want to write code for security or transaction management or pooling. Okay. I don't want to write code for this common requirements. I want to just declare what type of security I want. I want declarative security, declarative transaction, declarative polling. So I don't write code. I will just do declarations. I want declarative security, declarative transactions, and declarative polling. So any bus framework which allows me to configure declarative security, transaction pooling, all these enterprise level requirements, which provides this enterprise features declaratively. We call it as enterprise service bus. So any bus framework which provides the enterprise features like transactions, security, pooling, etc., we call it as enterprise service bus. I hope now you understood what is the difference between a bus and an enterprise service bus. But actually, all bus frameworks are enterprise service buses only, because all of them provide this declarative security, transactions, pooling, etc. Right? So now you understood that Mule is an ESB. It provides a way to configure all these filters, transformers, routers, etc. Okay, fine. Now you understood what is Mule. And by using Mule, you can avoid the point-to-point integration problem. If my application is directly communicating with the third parties, we don't achieve these couplings, right? So these are the problems with point-to-point integration. So we can avoid such problems if you are using ESBs like Mule. Okay? Because we just configure, our code will not change. Now, let me introduce you to a concept of what is orchestration. So you need to understand clearly about what is an orchestration. Let me explain with an example. Assume that there are a lot of third-party services, like you have service 1, service 2, and service 3. These are third-party services. Assume. Then this is your code, whatever, this is your application, and you have written your code. Whenever your application gets a request, it will get some data. Then my code will create a message which has headers and payload, and then put it in a queue. Now, I will configure an adapter so that it will make a call to service 1 using the data, and then it will get the response. So assume that it will send some payload X to service 1, it will get response Y. Then along with response, whatever it gets, it will create a message and keep it in the next channel, next queue. Then I'll configure one more component, which will actually send the data to service to get the response and keep it in another queue. So let's assume that here I'm getting the response as Z. Now from service 1, I've got Y. Service 2, I've got Z. Then maybe I'll configure a transformer which will use the data Y and data Z, transform it to another format or whatever data is required, and keep it in next queue. Then I will configure one more component which will take this transformed data and then invoke service 3, get the response, and whatever response it gets, it will give it back. So now in this case, my application, what is it doing? Whenever it gets the data, it is talking to multiple services and it is getting the desired response. So this process of communicating with multiple services and getting the desired work done is called as orchestration. So I can say that my code is orchestrating with S1, S2, and S3, right? And getting the desired work done. The process of coordinating with multiple services and getting the desired work done, we call this process as orchestration. Normally, in Mule, what we do, we create flows like this, which contain orchestration logic. Mostly in Mule or Mule application, we create or we write orchestration logic. Okay. So let us see step by step. Actually, I'll tell you a use case. Okay. Let us take a website as an example. I know a website called as smartrex.com. Yeah, this is a website in India. Actually, if I want to purchase an iPhone, what I'll do is I can go to multiple e-commerce websites and purchase. In India, we have e-commerce websites like Amazon, Flipkart, Snapdeal, like that. There are a lot of e-commerce websites. I want to purchase an iPhone. I want to get iPhone at a best possible price. So what I do is go to this website and search for iPhone. Okay. Let's say anything, iPhone 14. So you can see it is giving the search results. Okay, let me search for iPhone 12. Search results. So you can see um, price 53. And this is from where? Something. If I click on it, it is taking me to chroma.com. Actually, SmartBricks, what it is doing is it is querying to Amazon, Flipkart, Chroma. There are a lot of third-party websites which are selling the products. So, yes. Oh, my voice is breaking up. Okay, just give me a minute. I'll reconnect using a different network. Okay, am I audible now? Am I audible clearly now? Can you just confirm me?
Yes,
Anyone?
yes, Siva. Now it's better.
Okay. Hopefully, I guess now you will not see any problems because I have changed my network. I have multiple networks. Maybe that network was a little bit weak. Okay, I'll continue.
All right, thank you.
Okay. So assume that I am developing an application like SmartBricks, where it can get the products from different e-commerce websites and it gives me a result so that as a customer, I can buy from any of these websites. So assume that I am developing such a web application. It's a web application, right? So assume that this is my web application. Normally for web applications, we get requests from browsers. So from browser, some customer is searching for a product. The request comes to my website and he's searching for iPhone. And I have a lot of third-party web services given by multiple e-commerce companies. Like Amazon is exposing, assume it is exposing a soap web service for searching products. Flipkart is exposing using REST. And maybe some other company like Chroma is exposing, let's say, so. And maybe some other thing is exposing using a database. They're giving a database access. For example, now what my web application has to do, once it gets a search request for iPhone, my web application has to integrate, make a call to Amazon API, get the response. Flipkart API, get the response. Chroma API, get the response. Like that, my web application should integrate with all the other APIs, third parties, aggregate the results from all the APIs and give the response back. So in a web application, if I'm writing logic like that, it is not good. Assume that I'm writing this application using Java. Using Java code, if I'm consuming all this web services and all, it is really a big code. If you're writing integration logic within your web application, actually you have to write a lot of code. I am not saying it is not possible. It is possible, but you end up writing a lot of code, right? So actually, I will use a word. which is used by Mr. Mass Rosen, who is the founder of Mule. Actually, in your application, if you're writing code to consume the other service, or if you're writing integration logic, actually, he terms that a developer is doing donkey work. A donkey will do a lot of hard work. It will carry the data, right? He terms that the developer is doing a donkey work. If he is writing a lot of integration logic, now he says, hey, don't write all such logic in your web application. Write such logic in a separate application such that here we have the logic for integrating with whatever services and give the response. So the integration logic is written in a separate application. And my web application, whenever it wants the data, it will make a one single call to this application, which contains integration logic or the orchestration logic. So Mr. Mass Rosen says, write a separate integration layer which will contain the orchestration logic, and don't write everything in a single web application. Okay. So he actually proposes product Mule. If you're writing this integration logic or the orchestration logic using Mule, Mule will take care of all the donkey work. As a developer, you don't need to write a lot of code for integration. It is mostly configurations. If you are using Mule, integration logic is mostly the configuration. So you don't need to write code. So Mr. Math Rosen says, hey, developer, don't do all the donkey work. All the donkey work will be provided by Mule. Mule provides you with various types of components, ready-made components to be used so that you can just configure and you'll get the response. You'll get the data. You'll be able to achieve whatever you want by just doing some configuration. So Mr. Mass Rosen, he says, if you are using Mule for integration, it will take all the donkey work out of your integration. And as I told you, in Mule, the data is carried from one place to other, right? So normally in olden days, people used to use donkeys for traveling load. They used to keep load on top of donkeys and then they'll travel from one location to other, right? In that way also, Mr. Mass Rosen says, hey, using Mule, we transfer the data from one location to other, like how a donkey does, right? And also, this Mule will take all the donkey work out of your integration. You don't need to write much code. You will write less code and do configurations. So that is the reason why he named his product as Mule. I hope all of you know Mule is a type of a donkey, right? It's a crossbreed of donkey and horse. So that is the reason why he named it as Mule. Okay. So why Mule? Mule will take integration logic out of your application. You write your integration logic in a separate Mule application. Don't write integration logic within your web application. Write integration logic within Mule using its ready-made components. Then whenever your web application gets a request, you can just hit this Mule application. Okay. So that's where Mule fits in. Mule is a framework or a library or a tool using which we can write a integration layer. Integration layer. Don't write integration logic in your web application. So by using Mule, we can write integration layer. Okay. So that is what is Mule. So till now, I made you to understand about all these topics. Now, let us try to understand what is any point platform for Mule. Okay, fine. I guess just before we go into the next topic, let us have a short break of 5 minutes